That is the huge Mars problem inside NASA's moon plan. The moon is close enough for Earth to still matter. Mars is far enough that the mission has to become its own world. And that is why Artemis may be the most important test NASA has run in decades. Not because it proves Mars is solved, because it may finally show which parts are not. The real question is not whether humans can go back to the moon. The real question is whether the moon can reveal the Mars problem before Mars reveals it to a crew. That is the difference between a bridge and a bottleneck. And right now, NASA is still building both. The next episode follows one of those weak links directly, the hidden problem with returning to the moon. Because the Mars gap does not start on Mars. It starts with what the moon still has to prove. Earth is still near enough to shape decisions. Earth can still be a return point. Earth can still send help on a timescale that feels human. Mars breaks that comfort. At Mars distance, Earth can become advice instead of intervention. That is the first reversal. The moon matters because it is close enough to fail safely. Mars matters because some failures cannot be escaped quickly. So the real question is not whether Artemis matters. It does. The question is whether Artemis proves enough of the actual Mars chain before NASA asks humans to trust that chain completely. Distance gets the attention. Duration does the damage. Distance is easy to picture. Earth, Moon, Mars. A line gets longer. But missions do not fail on a map. They fail inside filters, valves, batteries, tanks, software, crew schedules, sleep cycles, medical decisions, food plans, and spare parts. One weak valve does not look like a Mars headline. One software reset does not look like a Mars headline. One bad sleep cycle does not look like a Mars headline. But a long mission gives every small weakness more chances to become the main event. NASA's Human Research Program lists 5 major hazards for astronauts moving deeper into space: radiation, isolation and confinement, distance from Earth, gravity fields, and hostile or closed environments. Those hazards do not stay separate, they stack. Radiation affects health, isolation affects judgment, distance affects medical care and resupply, gravity changes the body. Closed environments turn life support into a permanent dependency. The moon can expose some of these problems. Mars stretches them. That is why Moon to Mars sounds cleaner than the engineering reality behind it. The phrase sounds like a route.
The mission is really a chain. Launch has to work. Docking has to work. Landing has to work. Surface power has to work. Habitation has to work. Human health has to hold. Return has to be possible. Every part has a lunar version. Mars has the harder version. Near Earth, failure can still be a race. Race to stabilize the crew. Race to re-enter. Race to rendezvous. Race to bring astronauts home. Around Mars, failure can become a waiting problem. The crew may know what is wrong. Mission control may know what is wrong. But knowledge is not rescue. That is the brutal version of deep space autonomy. A doctor on Earth cannot step into the spacecraft. A spare part cannot arrive tomorrow. A damaged survival system cannot always be abandoned. And an abort option only matters if the mission gives the crew somewhere to go. The moon can practice autonomy. Mars can demand it. The moon can test life support loops. Mars can make the crew live inside those loops until they trust them more than they trust rescue. The moon can reveal radiation exposure. Mars adds time to that exposure. The moon can teach surface operations. Mars makes surface operations part of a longer survival chain. This is where the gap becomes real. If radiation protection is not mature enough, Mars stretches the risk. If food and water systems are not reliable enough, Mars stretches the dependency. If crew health monitoring is not autonomous enough, Mars stretches the uncertainty. If spare parts are planned wrong, Mars turns a small component into a mission-level problem. None of this means NASA failed. It means Artemis is the test bed, not the finish line. Mars is not just a destination. It is a system that has to be entered, survived, explored, and escaped.
If crew health monitoring is not autonomous enough, Mars stretches the uncertainty. If spare parts are not planned correctly, Mars stretches every broken component into a mission-level problem. Nothing here means NASA has failed. It means the moon plan is the testbed, not the finish line. And the testbed has to show more than footprints. It has to show that a crew can keep a deep space system alive when Earth cannot save the day quickly. That is why the infrastructure question matters next, because a crew cannot be self-sufficient if the architecture around them is still uncertain. The next problem is infrastructure. Mars is not just a destination. Mars is a system that has to be entered, survived, explored, and escaped. That last word matters. Escaped. NASA has landed many robotic missions on Mars, but NASA's Mars architecture material is clear about one thing humans have not done: orbital ascent from the Martian surface. Landing humans is only half the promise. Leaving has to work too, and Mars makes both sides harder. A robotic lander can be small compared with a crewed system. A human-scale mission needs mass, volume, life support, ascent capability, surface systems, protection, mobility, power, and redundancy. The Mars trade space includes transportation, entry, descent, landing, crew systems, surface systems, and ascent systems. That is a long list for a reason. Mars is not one technology away. It is an architecture problem. And architecture is where simple space stories usually break. Artemis helps because it begins building deep space habits: docking, crew operations, surface mobility, lander development, suit development, lunar infrastructure. But the Moon has advantages Mars does not. Its gravity is weaker. That is why schedule is not just a calendar issue. In a Moon to Mars program, schedule becomes architecture. If a lander is late, the surface plan changes. If spacesuits are late, the landing plan changes. If costs climb, cadence can slow. If cadence slows, the learning loop slows. And the learning loop is everything. The faster Artemis can fly, measure, repair, and fly again, the faster it can become reliable. The slower that loop becomes, the more each mission has to carry the weight of proof by itself. Mars needs the opposite. Mars needs a chain of proof strong enough that no single beautiful mission has to carry the whole dream. So the real test of Artemis is not whether one mission looks successful. The test is whether success becomes repeatable. Repeatable launches, repeatable crew operations, repeatable lander performance, repeatable surface work, repeatable suit function, repeatable power systems, repeatable logistics, repeatable recovery from problems. Mars does not reward one perfect mission. Mars requires a system that can absorb imperfection. That is the heart of the episode. If a lunar system fails, NASA can learn from it. If a Mars system fails at the wrong time, the crew may have to live with it. That is why the Moon is not just a destination. It is a stress chamber for the assumptions behind Mars. The assumption that hardware can scale. The assumption that crews can operate with less dependence on Earth. The assumption that surface systems can survive dust, cold, heat, and long exposure. The assumption that commercial and government systems can integrate into one reliable chain. The assumption that mission control can become less like a rescue center and more like a distant advisor. If Artemis exposes weak links early, it gives NASA a chance to fix them before Mars. If Artemis gets treated only as a victory parade, it can hide the Mars gap behind beautiful images. And beautiful images are not architecture. Footprints are not logistics. A lunar landing is not a Mars ascent. A short deep space flight is not a multi-year interplanetary mission. NASA's Moon plan is real progress. The Mars problem is that Artemis can prove parts of deep space exploration without proving the full chain needed to land, live, and leave Mars. That is the gap. And if NASA closes it, the Moon becomes the bridge. If it does not, the Moon becomes the place where the bridge stops.